In the early 2000s, competitive PC gaming was expanding into a global phenomenon. Titles like Quake and Counterstrike were drawing stadium-scale crowds and establishing esports as a legitimate professional competition. Inside those arenas, human reflexes were being pushed to their absolute limits. Players were forced to react in fractions of a second, snapping their hands across the desk to execute high-precision flick shots. But there was a primary bottleneck: the physical hardware. Competitors were navigating these high-stakes matches using standard office mice that were engineered for power efficiency, not for professional-grade performance. The central issue was wake-up latency. To conserve battery life, standard optical sensors were programmed to enter a standby mode during the micro-pauses between movements. This creates a measurable hesitation. When the player initiates a movement, their hand moves instantly, but the cursor lags behind while the sensor wakes up. In a high-stakes match, those missing milliseconds are often the difference between a hit and a miss. Professional gamers needed more than a standard peripheral. They required a specialized, zero-latency biomechanical instrument engineered specifically to match their neurological speed. Razer's 2004 response to this bottleneck was the Diamondback Plasma Limited Edition, a device designed using direct feedback from the esports athletes who were hitting those hardware limits. The technical core of the device was a 1600 dpi infrared sensor, providing a level of tracking resolution that standard optical mice couldn't achieve. Engineers addressed latency through an always-on architecture. They completely disabled the power-saving standby phase, creating a solid, unbroken infrared beam. This continuous beam meant the sensor was constantly tracking the surface. Even the slightest twitch translated immediately into on-screen action without any initial delay. Prioritizing absolute tracking fidelity over battery life shifted the engineering focus. It turned the computer mouse into a specialized instrument optimized entirely for high-speed response. Beyond the sensor, engineers focused on the physical chassis, stripping the device down to a slim profile with a mass of just 89 grams. There is a direct physical benefit to this flyweight design. According to the kinetic energy formula, a linear reduction in mass results in a linear reduction in the energy required to decelerate the mouse instantly. The ambidextrous, low-profile shape was tailored specifically to support claw and fingertip grips. This design effectively lowered the user's center of gravity, providing more stability during high-speed lateral movements. Data transmission presented another hurdle. At the time, Razer rejected wireless technology, which relied on heavy batteries and was prone to signal interference at crowded LAN parties. The solution was a gold-plated USB and braided fiber cable. This configuration delivered a 1000 Hz polling rate, ensuring the mouse transmitted data to the PC every single millisecond. Every physical dimension and material choice was calculated to strip away the physical and electromagnetic barriers between human intent and digital execution. The 2004 Plasma Limited Edition was both a critical and commercial success. The Swedish review reflects that reception, awarding the mouse a 6 out of 7 and highlighting its precision for fast-paced shooters. By the time Razer relaunched the Diamondback in 2015, the gaming landscape had shifted toward massive 4K displays. The higher pixel density required a significant increase in sensor capability. To navigate these high-resolution screens without physical exhaustion, the internals were upgraded to a 16,000 dpi 5G laser sensor. The new software allowed for deeper calibration, including a 0.1 mm liftoff cutoff that prevents the cursor from drifting when a player lifts and resets their mouse. While the internals migrated toward laser arrays and cloud processing, the external geometry remained untouched. The chassis and the 89-gram weight of the 2015 model were identical to the original 2004 release. Processing power and sensor resolution will likely continue to scale toward astronomical numbers, yet the physical dimensions developed in 2004 established a benchmark for ergonomic performance that a decade of technical advancement couldn't find a reason to change.